Alright, this is going to be the last one that we're going to do for this section of material, and this problem just looks crazy. It looks a lot more difficult, but what we're going to find when we get in to start working with it is that it's actually not bad at all. Alright, so this is just a mess, but in order to solve something that is this much of a mess, we're going to have to use our zero product property. So we're going to have to set factors equal to 0. Well, we've got factors over here and we've got factors over here, but this is just such a mess. Let's go ahead and try and clean it up first and just see where we're at. So let's go ahead and multiply out these binomials. So that's going to give us x times x is x squared, x times 3 would be plus 3x, and then 2 times x would be plus 2x, and 2 times 3 would be plus 6, equals. Let's go ahead and distribute this out also. X times x would be x squared, and x times negative 2 would be negative 2x. Now let's clean up what we have. We have x squared. If I combine like terms here, that's going to be plus 5x plus 6 equals x squared minus 2x. Now, we have to have it equal to 0 in order to start, at least. So let's subtract our x squared from both sides. And when we do that, let me just show that this time. When we subtract that x squared from both sides, we remove it from the right, but x squared minus x squared is gone even over on the left-hand side. So we have no more x squareds. What we have now is 5x plus 6 equals negative 2x. Now if we get our x's together, if we add 2x to both sides, we have 7x plus 6 equals, we don't have anything left over on the right. Now, we do have it equal to 0, but we don't have factors. But is that necessary in this problem? We just have a single x here to have to solve for. This is actually just a linear equation. We don't have to do any factoring. It's just solve it. So if we subtract 6 from both sides, then we will have 7x equals negative 6. And then if we divide both sides by 7, we have x equals negative 6/7. So we actually had a single answer for this problem.